In this video here, we're going to take a look at the bin packing algorithms. Now, the bin packing algorithms allow us to organize objects into as few containers as possible. Now, some real-life applications of this could include, for example, loading cars of different lengths onto a ferry with multiple lanes of equal length, or for example, cutting raw materials such as, say, fabric or metal into smaller pieces trying to minimize waste, and also recording music tracks onto a set of CDs. Now, there are 3 different bin packing algorithms that we need to learn how to implement, as well as the strengths and weaknesses of each algorithm. So the 3 bin packing algorithms that you need to learn are the first fit algorithm, the first fit decreasing algorithm, and then finally the full bin algorithm. Now, before we introduce any of these 3 algorithms, it is useful to first find a lower bound for the number of bins needed. So before we introduce the algorithm then, let's just take a quick look at how we can find the lower bound for the number of bins needed. So let's just take a quick look then at how we can find the lower bound for the number of bins needed. Now, when we find the lower bound for the number of bins needed, there's no guarantee that we're going to be able to pack the items into this number of bins. However, it will tell us if we have found an optimal solution. And an optimal solution is one that cannot be improved upon. So for bin packing an optimal solution, we'll use the smallest possible number of bins. Now let's just say then that we have the following numbers below. So what I've got here then is 30, 12, 7, 24, 15, 10, and 41. And what we want to do here then is pack these numbers into bins of size 50. So if we want to find the lower bound here for the number of bins needed, what we need to do then is sum these given numbers here, and we divide that by the bin size, which in this example here would be 50. So in that case, then the lower bound here is equal to 30 plus 12 plus 7 plus so on and so on, up to 41 all over 50, right? So we simplify the numerator here, that gives us 139, and we divide by 50 because 50 here is the bin size. And if we evaluate this here then, we get 2.78. Now what this means here then is a minimum of 3 bins will be needed or required because we need to round up here, right? So what that tells us then, a minimum of 3 bins will be needed here to pack these numbers into bins of size 50. Now, if we have a small amount of data, it is often possible to spot an optimal answer. And the algorithms that we will introduce in this video will not necessarily find an optimal solution. However, we can implement those algorithms quickly. So in terms of the lower bound there for the number of bins needed, that's all we need there. Hopefully this very quick example here just demonstrates how easy it is to find the lower bound for the number of bins needed, right? And the key point here, don't forget, is that we always need to round up, okay? So that's everything there for the lower bound. Now let's just quickly run through each individual algorithm. So to get us started here, then we have the first fit algorithm. Now, the first fit algorithm works by considering items in the order they are given. So for step 1, then we take the items in the order given. And then for the final step here, step 2, we then place each item in the first available bin that can take it. And just note here then that we start from bin 1 each time. And as we mentioned in the introduction here, we do also need to know the advantages and disadvantages for each individual algorithm. So in this case here, just the one advantage. And the advantage here is that it's easy to implement. And same again here, just the one disadvantage. And the disadvantage here is that it's unlikely to be a good solution. Okay, so that's everything there for the first fit algorithm. Now for the next algorithm here, we have the first fit decreasing algorithm. Now the first fit decreasing algorithm requires the items in descending order before applying the algorithm. So for the first step here, step 1, we simply sort the items so that they're in descending order. And then for the final step here, step 2, we then apply the first fit algorithm to the reordered list. So don't forget then, the first fit algorithm was the algorithm that we introduced on the previous slide. And again, let's just state the advantages and disadvantages for this algorithm. So for the advantages here, so for the first one, then we can say that it's quick to implement. And then for the final advantage here, it usually leads to a fairly good solution. And now for the disadvantage here, just the one in this case, right? We can say that it's unlikely to be an optimal solution. So the key point here is that it usually leads to a fairly good solution. However, it's unlikely to be an optimal solution, okay? And that gives us everything that we need there for the first fit decreasing algorithm. And now for the final algorithm here, we have the full bin packing algorithm. So the full bin packing algorithm uses inspection to select items that will combine to fill bins. And the remaining items are packed using the first fit algorithm. So for the first step here, step 1, we inspect to find combinations of items that will fill a bin. We then pack those items first. And then for the final step here, step 2, we then pack the remaining items using the first fit algorithm. And again, let's also just state the advantages and disadvantages for this algorithm. So for the advantage here, just the one right, we can say that it usually leads to a good solution. And then for the disadvantage here again, just the one disadvantage. It can be difficult to implement, especially when the numbers are plentiful and awkward. So that gives us everything that we need here for the full bin packing algorithm. And in terms of the bin packing algorithms overall, that's actually everything that we need here, right? So we've introduced each algorithm separately. We've, gone through some real life applications of the bin packing algorithms. And I think at this point here, that concludes this introduction, right? So as always here, I think the best way to really demonstrate the bin packing algorithms is to run through a couple of examples. Okay, so let's just get started then with question 1 here. And then finally, to finish with here, let's just have a go at the one practice question for this video. Now, as we can see then, what I've got here is all of these numbers. And what we're told then is the numbers above are to be packed into bins of size 40. Now, for the first part of this question, that is part A, all we want to do here then is calculate the lower bound for the number of bins. Now, don't forget then, for the lower bound here, let's just write this down. This is equal to, so it's the sum of all of these items here, so 15 plus 7 plus 20, plus so on and so on, all the way up to the very last number here, 30, and then we divide by the bin size, which is 40 for this question. Okay, so get 15 plus 7 plus 20 plus so on and so on. I won't bother writing down every single number, but you get the idea. All the way up to the very last number here, which is 30. Okay, and we divide all of this here then by the bin size, which is 40. So we divide by 40. And if you evaluate this correctly here, then what you should find is we get 4.5. Okay, so in that case then, the lower bound here for the number of bins required is 5, right? We need 5 bins at a minimum. So 5 bins are required. Okay, and there we have it then. So hopefully nice and straightforward there for part A. Now for the next part of this question, part B, what do we want to do here? So it just says pack the items into the bins using the first fit algorithm. So for the first fit algorithm then, we know that at a minimum here, we require 5 bins. So let's just start then by writing down the first 5 bins here. So bin 1, bin 2, bin 3, bin 4, and then finally, bin 5. Okay? Now, that isn't to say that we only need 5 bins. We might need more. And given that we're using the first fit algorithm, we're probably going to need more than 5 bins. It doesn't give a particularly great solution. But for now, I'm just going to start with the first 5 bins here. Okay, I'm just going to start with the minimum. So, with the first fit algorithm, we just start with the list as it's given here, and just pack each item into the first available bin. So for example then, 15 here can go into bin 1, right? So 15 goes into bin 1. Now 7 can also go into bin 1, right? Don't forget here, we're going up to a size of 40. So I've got 15, 7 can also go in. So that takes us to a total of 22. So I've got 18 units of space left here. So clearly then, 20 cannot go into bin 1, right? It exceeds the limit that we've got left there of 18. So 20 must go into the next available bin, which is bin 2. So 20 goes into bin 2. And what I'll also do here is just tick them off as I go, just so I can kind of follow along here. So 15, 7, and 20. The next number here, 11, can go into bin 1, right? So we had 18 units of space left, so 11 can clearly go into bin 1. Okay, so 11 goes in, like so. Now 35 clearly cannot go into bin 1 or bin 2. So 35 then needs to go into bin 3. So 35 goes there. Give that a tick. So for 13 then, well, clearly 13 cannot go into bin 1. So up to now, bin 1 has 15, 7, 11. So 22, 33, I've got 7 units of space left. So clearly 13 won't go into bin 1, but it will go into bin 2. Put 13 into bin 2. And for the 2 here, so how many units of space do we have left here? So I had 22, 33, so I've got 7 units of space left. So 2 can go into bin 1. So put 2 into bin 1. Give that a tick. 19 will not go into bin 2. It clearly won't go into bin 1, right? So it won't go into bin 1. It won't go into bin 2. It won't go into bin 3. So 19 then needs to go into bin 4. Okay? Give that a tick. Now for 28 then, so 28 here will not go into bin 1, clearly. It won't go into bin 2. It won't go into bin 3. And it also won't go into bin 4. So 28 then goes into bin 5. Give that a tick as well. And then finally here, we've got 30. Now for 30 then, that will not go into bin 1. It won't go into bin 2. It won't go into bin 3. It won't go into bin 4. And it also won't go into bin 5. So what that means then is we need an extra bin here. So I write down my next bin here, bin 6, and insert this number here, 30. Like so there, okay? And I'll give that a tick as well. Perfect, okay? And there we have it then. We've packed all items into the bins using the first fit algorithm. And there we have it then. So that gives us the solution there to part B. And then finally, for the very last part of this question here, part C, it wants us to pack the items into the bin using the first fit decreasing algorithm. So for part C then, let's just do that over here. Well, the clue is in the name of the algorithm, right? We need to start by ordering this list here from largest to smallest, okay? So the largest number here is 35. So I've got 35. The next largest is 30. 28, that's a 0 by the way. So 28, what's next? 20. 20 is next. After 20, we've got 19, 15, 13, 11, 7, and 2. There we go. Okay, so this here now is my decreasing list. So we now just apply the first fit algorithm to this list here. And again, I'm going to start with the first 5 bins, right? Again, we might need more than 5 bins, but for now, I'll just start with the minimum. So I've got bin 1, bin 2, bin 3, bin 4, and then finally, bin 5. Okay, so starting off then, bin 1 here, we can put 35 into bin 1. Perfect. And again, I'll tick these off as I go. I'll do it above though, to save a little bit of room. 30 then clearly won't go into bin 1. I've only got 5 units of space left here, so 30 needs to go into bin 2. Again, let's give that a tick. 28 clearly doesn't go into bin 1 or bin 2, so that needs to go into bin 3. So put 28 into bin 3. Perfect. So for the 20 here, that will not go into bin 1, bin 2, or bin 3. So 20 goes into bin 4. Give that a tick. Complete. For 19 then, so 19 won't go into bin 1. I've only got 5 units of space left there. It won't go into bin 2. I've only got 10 units of space left there. And it won't go into bin 3. I've got 12 units of space left there. However, it will go into bin 4, right? Because I've got 20 units of space left here. So 19 goes in to bin 4. Give that a tick. For 15 then, where does 15 go here? Well, it won't fit into bin 1, it won't fit into bin 2, it won't fit into bin 3, and it also won't fit into bin 4. So 15 then needs to go into bin 5. Okay, give that a tick. What about 13 then? So 13 clearly doesn't go into bin 1, bin 2, or bin 3. It also doesn't go into bin 4. So 13 then needs to go into bin 5, right? So at this point here, we had 25 units of space left. So clearly 13 goes into bin 5. Okay, give that a tick. What about 11 then? So 11 here won't go into bin 1. I've only got 5 units of space left there. It won't go into bin 2. I've only got 10 units of space left there. However, it will go into bin 3 because we've got 12 units of space left here. So we put 11 there like so and give it a tick. What about 7 then? So 7 won't go into bin 1 because I've only got 5 units of space left here. However, it will go into bin 2, right? Because I've got 10 units of space left here. Put the 7 into bin 2. Perfect. And give it a tick. And then finally, the very last number here, we're nearly there, right, guys? We're nearly there. So for the very last number here, 2, what bin does that go into? Well, clearly that just goes into bin 1, right? Because we've got 5 units of space left here. So we put 2 into bin 1, and there we have it. So we have now packed the items into the bin using the first fit decreasing algorithm, and this here is our solution, okay? And there we have it then. So that gives the solution here to the one practice question for this video. And that brings us to the end then of this video here on the bin packing algorithms.